Hello students, how are you? In this particular playlist, and we will just try to give you very small tips and tricks. और ये जो टिप्स एंड ट्रिक्स होंगे वो आपको बेसिकली अपने एग्जाम में टाइम मैनेजमेंट को कवर करने में एज वेल एज अपनी एफिशिएंसी को बढ़ाने में काम आएगा. So in this particular all series, we will just post a very small videos where you have to just focus on one particular concept और उसमें आपको बेसिकली क्या वर्कआउट करना है एग्जाम के पहले such that once you will go into the examination you can easily direct use this concept, direct use this formula, and you can easily solve the problem. So today students, I have taken two basic formula जिसमें आपको कुछ पहले से ही वर्कआउट करना चाहिए. And this formula belongs to molecular physics because I think this time there must be some question from the molecular physics because last year there was not any question from molecular physics. Rather, there are questions from the atomic physics. So let's try to go for this one. So students, अगर आप देखते हो तो what you will find that rotational constant is very important term into this particular molecular physics, and its use into this microwave spectra as well as Raman spectra also. So इसकी कैलकुलेशन को आप कैसे स्मार्टली करोगे ये बहुत ही इंपॉर्टेंट है. सो लेट्स ट्राई टू गो फॉर दिस वन. सो स्टूडेंट्स, suppose I have to use this formula where b is the rotational constant and what I have h upon 8 pi square c into I is nothing but the moment of inertia. So students, अगर आप इस पूरे एक्सप्रेशन को पहले से नहीं तैयार करोगे then it will take lot of time to do the calculation. So what we will do, we will just try to calculate this term before going to examination and we will remember this particular term because h 8 pi square and c, these all are nothing but what, universal constant. So what will happen if we are going to calculate this thing before going to examination and during the practice of our question, then what will happen, we can save our time very easily. And obviously, this I is nothing but moment of inertia. This B is a rotational constant. And we have to also take care that this B should be always given in a centimeter inverse. So we have to always take care of all this concept. So students, if I will put this value, H is nothing but 6.6 into 10 to the power minus 34 joule second. I am taking H in a joule second and we have pi square. So I have calculated the value of pi square. This will be almost 9.86. This is number. And what we have to do, we have to just put the value of C in a CGS. That is the trick here. Because once we will put the value of C into CGS, we will get this particular B in our centimeter inverse. So what is this value of C? This C is equal to 3 into 10 to the power 10 centimeter per second. And what I will do, I will take I as basically kg meter square. So what we have done, we have put each and everything into SI, but C we will put into the CGS. And once you will put all this value, then you can easily get this B is equal to, and I have calculated this one for you, and this is approximately equal to 28 into 10 to the power minus 47 upon I, and this will be equal to centimeter inverse. So if you are using this particular thing, if you are going to prepare before this particular examination, then what you can do, you can solve this type of question in just a minute, and that you can save this particular thing, the particular time also. The another thing into this rotational spectra is all about you have to find the maximum value of you have to find the value of J for which intensity will be maximum. And here we have also one very interesting uh, expression. So what is this particular J? This J is nothing. You can easily calculate it. That value is KT upon 2 HC into B. And you have to take minus 1. Now again you can find this K upon HC is something universal constant. So again what we will do, and B will be given into centimeter inverse. And here from you can get this J will be related to maximum intensity. So this is related to maximum intensity, maximum I. So for this particular value of J, you will get the maximum intensity at the some temperature, and this temperature is at the Kelvin. So again, you can put the value of K upon Hc. So once you will put the value of K upon Hc, we have H and C there. And what is your K? Your K is Boltzmann constant, and this value is 1.38 into 10 to the power minus 23 joule per Kelvin. And once we will put this value, then this K upon Hc, we will get a very interesting, that will be 0.695, that is centimeter inverse, Kelvin inverse. So what you can do, you can just rewrite this formula as J is equal to nothing, 0.695 upon 2 into B, and this B into centimeter inverse minus 1. So, and here is temperature is also given. This temperature must be in Kelvin. So what will be given? The temperature will given. You can find the value of B from here, and you can just get what will be the maximum value. So students, I am just hoping that some question from the rotational spectra or Raman spectra will come into picture, and this very short calculation, and before the examination, if you are going to prepare this calculation, then I hope that it will be beneficial for you. So students, if you want to get this type of tips and tricks more and more, then you should join our crash course, which is going to start from 28th June. That is 1 month course where we will talk about our crash course. We will talk about all the concepts. We will discuss very unique questions, as well as we will also tell you different type of tips and tricks where you can easily save your time and increase your efficiency. Thank you.